Okay, so just like with every other parent function, we are learning about transformations of logs. So what happened? I went to the wrong page. We have all of these facts about parent functions that we just wrote down on that previous page. We talked about the domain, the range, the asymptote, the end behavior. We didn't talk about the fact that the parent function does not have a y-intercept because the y-axis is the asymptote, so it's never going to touch it, but it does have an x-intercept, and that x-intercept is 1. The thing that's different about this than about log transformations compared to exponential transformations is that C is just about the only thing that causes your changes in your domain. Range does not change, but your domain, your asymptote, and your end behavior. But that should kind of make sense, because what does C do? C moves your graph left and right. And since your asymptote is now vertical, if I move it left and right, then you're going to be able to see that asymptote change. And the domain and the end behavior both involves that asymptote, the location of that asymptote. So when the asymptote is 0, your domain starts at 0. When your asymptote is 0, your left side is going to be approaching your asymptote. So this asymptote right here is what drives the answer to your domain and your end behavior. So as we change C, as we change the values of C, all of this information right here is changing. Okay, so we're still going to look at changes in A and C and D, and they still do the same things that, vertical shrink, shift left, shift right, shift up, shift down. But the only parameter that causes this information to change is that C value. So I'm going to jump over here real quick and look at, now remember we talked about we have 3 parent functions. Let's go back and write that down real quick. We have 3 parent functions. We have, just like with exponentials, we have base 2, base 10, and base e. So the same is true for logs. We have log base 2 of x, that's the inverse of 2 to the x. Those are inverse functions of each other. And then we have the parent function just log, no base. There's actually is a base, it's just understood base 10. That's the inverse of 10 to the x. And by the way, that's called the common, this right here is called the common log. We say it's log base 2 of x. That's how we read that, log base 2 of x. This is log base 10 of x, or we could just call it the common log. And then the third one is the inverse of y equals e to the x. We know that that's the natural exponential. So the inverse of that one is the natural log of x. That natural log right there does actually have a little base e, just like that has a base 10, that has a base e, but it's understood, and we call this the natural log. Natural log, common log, log base 2. Those are your 3 parent functions. According to the state of Texas, we only have to teach those 3. So on the Desmos thing, I put the log base 2, I made it a dotted line. You can see it's kind of in the background right here. It's that black dotted line. So as we change this red one, you can compare the red graph to the parent function. I left it stable so it wouldn't move, so you can see the changes. So here are our parameters. A is the multiplier that's out in front. C is the number that's being added or subtracted to the variable x. And D is the one that's being added or subtracted to the entire thing. So we say that C is an inside parameter because it's being added only to the X. D is what we call an outside parameter because it's being added to the log of X after we take the log of it. So our parent function, which is this black one up here, it does have an A, a D, and a C. We don't see them, but we understand that there really is a 1 right there. 1 times. Notice when I did that 1 times, it did not change anything. It just moved the dotted line on top of my red one. But if you don't see, the red one's still there. But we did that 1 times. It didn't change it. So it's the same thing as if it's always there. If I put minus 0 right there, nothing changes, because even if we don't see a number added or subtracted to the X, then we know it's a 0. And if we put plus 0 right there, then nothing changes. So again, even though we don't normally see all of those values, you can understand that they're there. The log base 2 of X has an A value of 1, a D value of 0, and a C value of 0. Okay, so I'm going to go now to the red graph, and I'm going to see, let's do C. Since C is such an important one, I want to show you C. I guess I should also, let's graph the asymptote. The asymptote is X equals C. There we go. It's X equals C. So should be, let's change the color of this real quick. Let's change this to, let's make it be, how about blue? And let's make it be dotted like that. Okay, so as I change this, now you can see that the asymptote is moving with it. So we can see easily that the values of C move the graph left and right. If C is a positive number, we move it to the right. If C is a negative number, it moves to the left. We can see that the asymptote is changing. My asymptote matches my C value. So if my asymptote is at 2, that means that C value is 2. If my asymptote is at -4, that means my C value is at -4. That means that my end behavior and my domain has changed in the same way that C has. Okay, so C is also changing where it crosses the x-axis. It changes the x-intercept, and if we move C this direction, now we do have a y-intercept. And the y-intercept probably can be calculated by knowing what the value of C is, but there's some other things involved too, so we're probably just going to leave y-intercept to visually knowing what the value of that one is. Okay, so now you should go back to this page right here, and let's fill in what we know about those values of C. What are some transformations that are caused by C? You could write down what this says, what are some transformations that are caused, and give yourself a few examples. And I will come back and we can compare our answers. Okay, so this one right here says that C is less than 0. That's how it reads, but what it says is that C is negative. And we know that if C is negative, then it's going to cause a shift left. Don't forget that it's going to change my domain, my end behavior, and my asymptote. That symbol right there is a triangle, and the triangle, as y'all have learned in all your science classes, stands for the word change. And then don't forget though, if C is negative, because of the equation that we have up here, because of the equation that we have where it says x minus c. When c is negative, you're actually going to see a +3 because we have x minus a -3. So that means this, you're going to see a +3, but you have to remember that that means c is negative. So this moves left 3. This one's going to move right 1. This one's going to move, move left 3, move left 1, move left a half. C behaves opposite of what you think it should.